Hi, my name's Jim Burrow. Along with my wife Di, we own the house that we're in at the moment, and at the end of November last year we installed, or had Solar Backup install a solar system for us. At the moment we're down here in what is in effect the cellar of the house, underneath the ground floor level, where it's a little bit cooler, where we were able to position the inverter and the batteries. Paul advised us that if we could find a relatively cool and stable temperature area, it would increase the longevity of the complete system. So we're able to do that. As you're looking there, the inverter is located there, the switching gear there, and just in behind me here the battery backup that we included in the system. My background has been a facilities manager, looking after buildings and grounds at various tertiary institutions and for a couple of major companies. Accordingly, I was fairly critical in our selection of people to install the system, and at the end of the day we're more than happy to accept Solar Backup as our installers. Our system starts generating power from probably a little bit before 8 o'clock in the morning and runs through currently till fairly close to 8 o'clock in the evening. The peak output of course being from probably 10:30 through till maybe 4:30 in the afternoon, where it reaches and maintains maximum capacity. We've adjusted our usage of power so that we are drawing from the system during the day. For example, the dishwasher goes on in the middle of the day, the washing machine goes on in the middle of the day. I'm sure that the swimming pool pump and filtration system again is on during the day. Even with that, we are still contributing quite a reasonable amount back into the grid, certainly more than enough to, in fact well more than enough to offset anything that we do draw from the grid where we've had to put a bit of a load on the batteries during the previous evening. Yes, we haven't encountered blackout as yet, fortunately, but certainly we understand that it will provide our blackout protection and emergency lighting to a couple of key circuits in the house. I imagine at some stage we will put that to the test, but we've been fortunate up till now. During the evening we run a fairly substantial television size thing, and that's usually on till about midnight or thereabouts, and our fridge, I think, puts a fairly constant demand. It's a fairly large fridge, but not a particularly efficient one, and the system will generally maintain until the battery level gets down to a set point that was installed by Solar Backup, at which stage then we will draw from the grid if additional power is required. Our experience through the summer period from November through now to the end of January is that we'd be lucky if we've absorbed anything more than 1 kilowatt hour from the grid, and that's usually around about 6-7 o'clock in the morning when everybody turns the coffee machines and electric kettles and so forth on. So we've been pretty happy with the performance of it up to date. System basically panels on the roof, inverter down in the basement, some backup batteries with the inverter, and the other component of the system is the power router data, and that's showing on the screen at the moment. Very simple login process, and you open it up and what they call the dashboard appears, and these are a series of what they term little widgets. We've found this being somewhat sort of technical and an anal engineer, very interesting. We'd probably visit this 2 or 3 times a day, just to monitor that all is going well with the system, but also to examine how much, to get a feel for how much we're generating and where it's going to during what is now the summer period. So the normal first thing that we would look at is solar yield for the day, and that's simply a matter of clicking on this little widget here, and it will produce a bar graph, in this case starting at about 8 o'clock in the morning, when the sunshine hit the panels, or a little bit before that, and it grows up on a scale of kilowatt hours, and it is now running at its design and nominal level of 5 kilowatt hours, in fact a fraction over on this one, and that will, given the look of outside today, will probably run through until maybe 4:35 in the afternoon, and then we'll taper down, and by about a little after 8 o'clock will be zero. So that gives us an indication that everything is generating, and as time goes on this information simply appears on the screen. We can then go up the top, that's our total yield for the day, and we can have a look under distribution, and what the distribution tells us is where in fact is all that power going. So the yellow, which is direct self-use, in other words it's going straight through the system and into an appliance, or such as the fridge or even this computer we're working at, you'll see that we take a relatively small amount, that's the yellow there, until about, in our case, about 12:30, 1 o'clock or thereabouts, when the pool pump kicked in. And so therefore that's our self-use, that'll maintain like that. If we had, for example, the washing machine on and fridge, and maybe an iron or a kettle or something, the self-use might kick up a little bit. Overnight we would have drawn a little bit of power from the battery, so at that stage in the early part of the day, normally up to about 12 o'clock, the green there is where the generated power is going to recharge the batteries. At the same time it is starting to feed back into the grid. There's a little bit of further information on this thing. We have 2 strings of photovoltaic cells, one facing to the north, which is the orange one down the bottom, and one facing to the west. So as the day goes on, the north will maintain and then start to fall away, but the panels facing west will maintain the bulk of the system. Yesterday, for example, gives a guide there, and you can see the north facing panel closing by about 6 o'clock, but the west facing still picking up quite a bit through till, and it closed at around about 8 o'clock last night. That we look at initially, it's the first component. Very easy to use. You can do as I just did then, go back a day, go back a further day, and there's the data for that day. You can also judge it by week or month to give an indication of the performance over the month. Slip out of that. So that's one little component we look at. The next thing is to look at consumption, to give us an idea of where we're actually consuming the power. And through the night, from midnight, we've been using about a quarter of a kilowatt hour fairly constantly through until about this morning, when breakfast time or a little bit after appeared, when it has kicked up a little. I think we may have had the dishwasher on briefly at that time, and then through the day till when, of course, the the pool pump came on. Comparing to previous charts, of course, the graph here adjusts, so this is still only 1.5 kilowatt hours consumption. The generation is still somewhere up the top of and beyond the top of the computer screen. Again, looking at what we've consumed, we then get a bit of information on where we've actually drawn the power from. This has been drawn from the battery, the blue over the night. A little bit of brown probably came when the battery was, we were using direct self-use plus a little bit of battery, and probably put a peak load system on, such as a kettle or something of that nature, and it drew perhaps a little bit of power from the grid. Then it has just continued, and we've been using basically only self-use in terms of what we've consumed. So, as I said before, from the grid shows up in brown, and there's only been the one little bit. We've taken power from the battery through until the sunlight appeared on the scene, and that's provided all the power that we've actually used since that time.
Have a look at yesterday.
Sorry, quick look at yesterday. So there, yesterday again from midnight, using a bit of battery power down until around about 7 o'clock or so in the morning, at which stage we also drew a little bit from the grid, and did so for a while. I think yesterday morning was fairly cloudy early in the piece, so we were drawing from the grid until the sunlight hit in around about 9 to 10 o'clock, and we then proceeded to direct self-use with occasionally, I think we put a couple of extra loads on at that stage, and it then continued to draw from the battery to make sure we had enough. Self-use then through until about 7 in the evening, when we started to draw a little bit from the battery.
Have a look at a month.
Sorry, and a month. A good indication, so spread over a number of days there. The yellow, again, just direct self-use that we've used. A little bit that we've drawn from the grid. One fairly savage demand on a day there when, or for a period of time on a day that I can't remember. There was a good reason for it probably. And the rest of the time we've also put some demand over the day on the battery. The system has certainly works well. As I say, it goes direct use unless the load is too high, at which stage it'll then draw a little bit from the battery. If the battery has the capacity, it will look after us. If not, then the inverter also draws from the grid. I'm up on the upper level on the balcony, and Paul is up on the roof. I'm sorry I can't get up there to display it, but I have a bit of an ankle damage that doesn't like climbing up a rung ladder. But Paul is showing our array of 28 panels on the roof, 2 strings of 14, one string that Paul is looking at generally at the moment, faces west, and that's the one that generates the bulk of the power in the latter part of the afternoon. And the other string faces north, and that generates the power from about 8 in the morning probably through till about 4 in the afternoon. The other effect of the panels on the roof, of course, is that has added to taking a bit of the heat load from the roof. I mentioned in an earlier video that combination of the panels, insulation and the bio-PCM phase change material has certainly made the upper level of our house a lot more livable. In essence, we get a readout here from how much we're consuming and how much is going into the grid, and to ensure that that works and works very efficiently, the installer's solar backup installed this little green wire here that runs down to the inverter and picks up very quickly any change in direction of current flowing through the meter, so that it knows when to switch us to battery power or direct power that's being generated